everyone, I'm back here with another video on evaluating the derivatives of functions. Guys, in my previous videos I talked about the product rule and the quotient rule, and we had already discussed the power rule. So guys, in this video and in the coming videos I'm going to actually take up some examples using the product rule and the quotient rule, and of course we will still be using the power rule. Guys, here you can see that there's a product of two functions. Yes, one can actually distribute this and multiply it through and then just use the power rule to evaluate this derivative. That is something that we can do. But guys, that's going to be really time consuming, and then there's a lot of steps involved. But that is still something that one can do. But in this case, I'm not just going to distribute everything out. Rather, I'm going to just use the product rule, because we already have discussed and introduced the product rule. So guys, without wasting any further time, let us go ahead and start using the product rule on this. So to use the product rule, the first thing that I like to do is I like to identify this as my f function and this as my g function. Guys, you can call this f and this g, it does not matter. But what is important is to kind of recall what is the product rule. So product rule applies when you have product of two functions and you are trying to take the derivative. And guys, it would also apply for if you have product of three or even more than those, okay? But there's going to be more steps involved in that. Here it's not going to be too many steps. So whenever you have the product of two functions and we are trying to take the derivative of those, then it is equal to the f prime times g plus g prime times the f. Guys, I still like to write this before I start applying it to any particular problem, and in this case I have identified my f and g and I'm just going to use that. So h prime of x is going to be this, I'm going to just use the product rule, so f prime, so I'm going to take the derivative of this here. So we already know to take the derivative of these individual pieces, one has to use the power rule. So I'm going to bring that 3 halves, and then it's x to the power 3 halves minus 1, which is going to be just 1 halves. So I'll put it in the parentheses, and then minus, I still have to take the derivative of 4x, and the derivative of 4x is simply minus 4. That takes care of f prime. Guys, I'm just applying this, and I like to write it so that I can see what I'm supposed to do. Then times g. So with g, I don't have to do anything with that g function. All I have to do is I just have to rewrite it, and it's just x to the power 4 plus, sorry, it's not a plus, it's minus 3 over x squared and plus 2. That takes care of this first half, and then I have a plus. And what am I supposed to do now? I'm supposed to find the derivative of the second function, the g function here. So let us go ahead and find the derivative of the second function. Derivative of these three pieces, x to the power 4, using the power rule, is 4x cubes. And then this is, guys, minus 3 is a constant. Guys, this guy, you can think of this as negative 3 and x to the power negative 2, because we have to bring that x squared to the numerator so that it looks of the form x to the power n, and then we can use the power rule on that. So using the power rule on this guy, it's going to be, well, negative 3 will stay. You got to bring the negative 2 up front, then x to the power negative 2 minus 1, which is going to be 6x to the power negative 3. So I can actually just, because we already simplified it on the side, so we just bring it here, plus 6x to the power negative 3. Let us check our work. Minus 3 minus 1, yeah, everything looks right. And then, guys, the derivative of a constant plus 2 is, we already know, is 0. Derivative of any constant is just 0. So this is already done. G prime, and we just have to multiply by the f function, which is x to the power 3 halves minus 4x. So guys, I think that is it. Like, we don't have to do anything further with it, unless it says you got to simplify the whole thing, which is going to be a lot of work, which is like, then you may have to like distribute these things. But most of the times they are not going to, like the textbook or any other places, they are not going to ask us to actually simplify this, so we just leave it like this. So guys, this whole using the product rule thing is not too complicated or too difficult once you remember or once you understand how the product rule works. But it's just like the final answer kind of does not look so pleasant. It kind of looks ugly. There's so many terms, and they're multiplied, and there's fractions, and there's these exponents. But guys, whatever it is, this is how you get how you use the product rule and you get the final answer using the product rule. Okay. So this is the first example for the product rule, nothing really fancy or complicated about it. And I'm going to show you some more examples of the product rule. Maybe one more example on the product rule, and then we'll do 2 examples on the quotient rule before moving into the chain rule and some other techniques of derivatives. Okay guys, till then.